是我们的最高工程负责人林宏安。这几位如果是有材料的，可以直接问范伯利。那关于混凝土一些专业性的问题，可以请教这2位博士。那施工的方面可以请教我们这位林老板。那虽然很年轻但是他1年所施工的那个坪数是非常惊人的，大概都有10万至20万平米上去所以他的经验是非常的丰富。那一开始我用这句话分享给各位今天有很多是有些是本身是司马的客户，那有些也是跟我是同行的，也是土料商。那我们举办这个活动就是说我们是一个很公开一个分享平台，那大家一起来学习，一起来成长所以如果当你开始走出去，路就变出现了，就是说各位都老板很多东西都要亲力亲为，很难得说如果一个下午你们可以腾出时间来这边跟大家做学习，然后来听听看专业讲者跟你同行的之间，他们在专业的地方在哪里，差异在哪里，优点在哪里。那我们需要打开我们的心胸去看看别人在讲什么这样子。因为我前2年有办研讨会刚一开始那个影片你们有看到，我前2年办研讨会是跟德国 CHT 合作那我邀请几位专业施工客户他有一些比较特殊工法。那我第1年办的时候那同行之间一定是同行相亲，这是一定道理那办完之后，有些客户说他做那个不一定有用听听就好。但是第2年我一样又邀请同一位来讲，然后讲完之后，一样有些客户会跟我讲说你又请他来干嘛？他做了又没用这是我获得的资讯但是其实我知道他已经在采用他工法了，而且这2年他有赚到钱所以我要分享就是说，来讲的人跟一起来听的人，大家都可以互相做交流那打开你的心胸。那接下来我们进入主题瑞士过来范伯利在瑞士已经将近100多年的历史那我先播放一首他们的歌他们俗称是他们校歌。他们满100年的时候这首歌是另外有群叫作曲的，所以他们是有版权的。然后整个工厂整个人来跟大家打个招呼这样子
Watch them grow. it's true. We make it best for you.
这是范伯利的那个属于他们的歌曲哈。那我们跟国外的品牌合作，其实不只是材料跟一些技术方面，我觉得我们在台湾需要学习他们的品牌、他们的教育，还有他们的理念。所以你说台湾很多涂料商，包括我们自己哈，虽然我们自己也很想做一首歌哦，但是因为我们还没100年，所以我们要再持续努力哈。所以那我们今天进入第一个主题哦，由于我们今天那个瑞士的那个讲者他讲英文，那我们同步会请新加坡的技术经理，他同时翻译成中文，所以是同步的。那大家如果在不懂的地方还是听不清楚的，我们告一段落的时候，我们再举手发问，哦，这样会比较流畅。我们先来让他们感受我们台湾人的热情。我们先来为我们第一位讲者跟来自瑞士跟新加坡的范伯利原厂人员来一个掌声鼓励。
So, ladies and gentlemen, thank you for coming. And first of all, I would like to thank our friends from Lionhorse giving us the possibility to have some presentation here to try to show you a little more on silicates. As I've seen before, if you step out on the way begins to appear, and I hope I can help you to find the exits, to find the entrance to silicates within my first presentation, which is based on, let's say, some basics on this very strange inorganic material. Natural relationship, reactions, some words on structures, some words on applications, just to show you how versatile this chemical can be. The first picture, I looked and searched a long time till I found a good picture of the Swiss Alps, because this is displaying more or less what our silicates in fact are compared to nature. The mountains you see here, the Alps of Switzerland, they consist of silicates. This is feldspar, this is quartz, and this is mica. Together, it is known as granite. So, going on to the build-up of our Earth, we can say the following. Okay. Our Earth, as we walk on, is built up of several layers. The first layer, the inner core, and the core, I don't want to go into it. This is mainly iron and nickel. On the other hand, the mantle and the crust, that's very interesting, consisting of a lot of oxygen, a lot of silicon, some aluminium, some iron, depending on where you are, lots of magnesium and some calcium.
OK， 环境中的矽酸盐，基本上在地壳跟地幔里面最多的含量是含氧，还有硒，之后就有铝、铁、镁，还有钙，这一些的含量会比较少。
What we can do from the build-up of these two things, crust and mantle, we can calculate on the SiO2 content, because silicon in nature almost exclusively is present as SiO2. So if I take the 28% of silicon together with the necessary oxygen, I will end up in roughly 60% of silicon dioxide, where the crust is built up of. We will have another 46% in the mantle. If I go further, take the remaining rest of oxygen and combine it with the metals we have seen before, aluminium, magnesium, calcium, iron, I will get all the minerals consisting of SiO2 and metal oxides, coming up to a total amount of silicate in the Earth's crust of about 90%, and the mantle almost exclusively consists of silicates. So all materials that are quite close relatives to the liquid alkaline silicates we produce and sell. The 8% of carbonates, everybody knows from paint, from whatever, calcium carbonate, magnesium carbonate, marble, and the remaining 2% chlorides like rock salt, or sulfates like, for example, gypsum.
OK， 基本上在环境中最多的元素是氧跟硒。基本上硒作为二氧化硒，大概含有68%的含量。硒作为矽酸盐和石英，在地壳和地幔当中就含有90%到100%的含量。其余的是碳酸盐，含量是8%。然后还有硫酸盐跟铝化物是含有2%左右的。
Just remaining a few seconds with this slide. I was talking about silicates. So what are silicates? Silicates are salts. They are comparable with sodium chloride because really it is a salt. We have aluminium oxide and silicium dioxide giving perlite. But all is a salt. Not every salt is soluble. We know perlite is insoluble in water. We know all the glasses, like window glass, is insoluble in water. But the special case of alkaline silicate glasses, like sodium silicate, potassium silicate, and lithium silicate, are water-soluble substances. So what do we have to do in the production? We shorten this a bit. The main points are, we need a furnace. We need a furnace exactly the same as you need to produce window glass. The only thing we do not use any calcium. We just use sand and potassium carbonate. We melt it in the furnace at 1400 degrees centigrade. The dwell time in the furnace is about 24 hours. And what we obtain are glass pieces, uneven glass pieces. One of our major raw materials, the potassium silicate lump glass.
OK， 这边我们谈到的是原料和其生产。基本上我们是在大概1400摄氏度里面，在窑炉中，我们混合砂纸和矽酸钾混合均匀，然后在窑炉中融化。冷却后，我们有一个主要原料，就是矽酸钾玻璃块，它是透明的。
Step 2 in the production, after melting the glass, is putting it into water, putting it into a dissolving tank, and dissolve it. What we get are solutions quite hazy, quite high in turbidity, which we feed to a pressure relief filter, and in the end, obtain the product you most probably know, odorless, colorless, possibly slightly yellowish solutions with different viscosities.
好的，在窑炉过后，我们就会得到块的玻璃细酸钾玻璃块。我们将细酸钾玻璃块溶解在水中，并在压力片中过滤器过滤已获的所谓的细酸盐液体状态。最终的产品是清澈无味，颜色较浅，至略带黄色的溶液，具有不同的粘度。
As next step, I would try to give you some insight on the structures of the soluble silicates. What you can see here are macrostructures. This was a test for fire protection glass. So a dried silicate layer just put in the furnace or in the oven, heated to about 300 degrees, and looking how it foams up. So that's what you can do with silicates. At the moment, known to man are more than 1,200 different structures of silicates. Most of those are minerals. But out of those 1,200, about 400 structures are present in every soluble silicate. So soluble silicate is not a defined chemical. It's a really big mix of hundreds of different structures. Furthermore, they do not only coexist, they also interact. They can change into one another, bindings breaking off, bindings new formed. So at the end, we've got the chemical equilibrium. Just to summarize, the other structures are things like different silicates, olivine, epidot, bentonite, all minerals you most probably will know.
好的，我们谈到细酸盐的结构，其实今天已经描述了超过1200种不同的二氧化硒。在每一种细酸盐溶液中，我们都可以找到大概400种这样的结构，它们是共存、相互作用，并且相互变化，形成化学平衡。OK， 这一些结构其中也包括橄榄石、锆石、云母、高磷石、质石等等的结构。
As you can imagine, with a mix of 400 different structures, it's almost impossible to predict how such substances or such mixtures will react. So most of the information on applications we have are not from trying to figure out what could happen, but testing what really happens. So what we do starting with is crystalline silica or silica sand. What we could obtain if we do not add any carbonate and melt it and shock freeze it afterwards, you will get a quartz glass. So changing the crystalline structure into an amorphous one, you can use as a glass. Or you add alkali silicate and earth alkali silicate to get window glass, or just alkali silicate, sodium or potassium to get our soluble silicates or water glasses.
好的，我们在这里有看到不同的二氧化硒的改性，其中也包括了石英晶体、石英玻璃，还有碱金属细酸盐玻璃。
What we haven't talked about so far is the molar ratio. So how do we define those wild mixtures of silicates? We define them by the ratio SiO2 and potassium or sodium oxide. What we can say to the molar ratio, so the higher it is, the more silicium dioxide I have per molecule of alkali metal, the higher the viscosity will be at the same concentration. So a 30% solution, 4.0, has much higher viscosity than a 30% solution having much less SiO2 and much more sodium or potassium oxide. On the other hand, higher molar ratios tend to dry faster. They harden faster, but they're also affected by low temperatures. When freezing, they will not be defrostable and be the same substance, so you have to remix, you probably have to heat up. And the higher the molar ratio is, the higher the SiO2 content becomes, the more we have a glass character, and thus the more stability against acids, against chemicals are present. On the other side, if we lower the molar ratio, the density will be higher at the same solid content. It will be easier to dissolve. We can go higher in solid content, but we will have higher pH values. Chalking tendency will rise, so there is more carbonate formed and transported to the surface, but the binding strength and binding ability will rise and the reactivity is higher.
好的，基本上硒酸盐是由摩尔比来断定它的性能的。越高的摩尔比就会有越高的粘度，在相同的浓度下，然后它们的干燥速度也越快，硬化速度也快，但很容易受冻害。然后它们的硬化涂层的化学稳定性是很好的。越低的摩尔比就有越高的密度，在相同的粘度下。它们的可溶性也是很好的，也是有很高的碱酸度，粉化倾向就是二氧化碳的形成，然后有粘合能力，反应性也很快。
Talking about viscosity, as we said, the higher the molar ratio, the higher the viscosity, but also the higher the molar ratio, the faster the viscosity rises by rising solid content. To display this, I took some photos of samples I normally have with me, but bringing those by plane to Taiwan is a little of pain. So what you see here is a potassium silicate, molar ratio 4.0, 29% on the left, 31% in the middle, 33% on the right. So this one here would be our 28 Bome K2837, one of the sales products.
OK， 这个图片里面我们可以看到固含量的上升，在摩尔比式的硒酸钾的溶液，从左到右，那就是29%、31%跟33%的固含量，我们可以察觉到，在29%的固含量的时候，它的粘度是比较稀的。而在33%的固含量的时候，它的粘度是很粘的、很高的。
As a next step, I just led those bottles to the side and let them rest for 1 minute. And what you can see, the 29% solution almost immediately went flat. The 31% solution still is moving, and the 33% solution almost haven't done a movement except here.
好的，在这个图片当中，我们可以看到固含量的上升，在摩尔比式的硒酸钾溶液里面，我们放在一旁1分钟，然后我们从左到右，我们可以察觉到，在低固含量29%的时候，它的液体是很容易形成平衡的。然后越来越慢，越来越慢，直到33%的固含量的时候，它是几乎不动的，它要的时间会比较长。
Then I waited for another 39 minutes. So after 40 minutes, also the 31% solution went flat. The 33 still is moving. We are talking here about a viscosity of 40 to 50 CPS. Here we are talking about, let's say, 5 to 10,000 CPS, and here we are surely above 50,000, just by 4% more or less solid content of the same substance dissolved in water.
在这图片当中，我们可以看到，在放在一旁40分钟之后，在低固含量29%的时候，它很快就形成平衡了，而33%的固含量的液体，它需要很长的时间才会形成平衡点。 所以它的很明显，从钴含量29%到33%，它的变化是很大的，它的粘度是逐渐的上升。
You surely can imagine if you need such a silicate for impregnating concrete, for example, this one with 50 CPS will most probably penetrate a little, so even this will have to be diluted. This one will just sit on top. So it's more or less a question of the application you have, whether you need a viscosity like this or a viscosity like this. So nothing we cannot change quite easily. As a next point, I will try to give you some insight on possible reactions the silicates can do. But to react, we need something called a reactive center. Once more, the amorphous structure, the silicate chains, the alkali metal ions, but where is the center here? In fact, it's not only one, it's a lot. This is one. And if we try to do it, to draw it in a way that you can see, it will look about like this. Once more, as I mentioned, we are talking of a salt. We have a negative oxygen and we have a positive potassium ion covering this, making it electrically neutral.
在这图片当中，你可以看得到它的反应中心。然后这一边，在我的右手边是放大的结构，其中它就是阴和阳结合，形成一个盐的成分。
So what do we do in our production if we have to adjust the molar ratio? We put in caustic soda, caustic potash, depending on the silicate we have. And what happens is, some of the bondings will break and the potassium is brought here, water is formed. So that's how the silicate reacts if we put in some alkalinity.
我们可以看得到二氧化硒与可性碱反应，其中我们会形成硒酸钾，还有水的形成。
What happens if we put in some multivalent ions? So what we produced here, together with magnesium hydroxide in solution, will form salts like this. Magnesium silicate. Magnesium silicate is not soluble in water, so this will precipitate and the KOH is formed back. You normally see KOH is consumed, water is formed, magnesium oxide is consumed, KOH is formed.
好，在第二个反应当中，我们可以看到它与多甲离子反应，形成不溶性的硒酸盐。在这边我们可以看到是硒酸镁的形成，这个硒酸镁是不溶于水的。
So that's more or less our daily business in our production sites. That's a reaction some of our customers are doing, producing magnesium silicate, calcium silicate as fireproof materials, for example. What happens when there is CO2 present? As normal with salts, this is a very weak acid, this is also a very weak acid in aqueous solution, but still this one is stronger than the silicic acid. So what happens? Silicate will precipitate and the potassium carbonate is formed again. That's what happens if you put a silicate on concrete or if you use it as binder in a paint. At the end you will have the silicate chains and the potassium carbonate formed back.
好，在这里我们就可以看到与二氧化碳的反应，就所谓的碳化，就形成一个碳酸钾。
Furthermore, we are talking about silicate chains, so we are not talking about defined molecules, we are talking about the kind of inorganic polymers. as a big difference to organic polymers. If we dissolve those in water, or if we add or remove water, there will be reaction. So silicate chains do react with the solvent. Other polymers don't. They remain as they are, but the silicates, they react. So if I remove water, the chains will combine. If I add water, the chains will break open. And that's more or less what you have seen with the 3 bottles before. The more water I get out, the longer, the more cross-linked the chains will become, and the higher the viscosity will be.
好，在这里我们是看到与溶剂水的反应，它含有干燥和化学平衡。
So what does our customers do? There are other customers, they just take the sodium silicate and put hydrosulfuric acid to it, and what happens is you have a precipitation of silica. That's how precipitated silica is produced. Once more, the sodium sulfate will be formed and water will be released.
这里我们可以看到与硫酸的反应，形成二氧化硒沉淀物。
And the same in the production of silica salt, for example. Some of you will know silica salts. So you have normally an ion exchanging process, picking out the sodium ions, putting in protons. You will get as well a precipitation of silica, but in this case not really a precipitation, but those particles are that tiny nanoparticles that they stay stable in the solution, so form the silica salt.
这里是与离子交换剂反应了，形成一个硒溶胶的制作。
And then we come to the most essential and necessary reaction in construction works. So as soon as liquid alkaline silicates meet substrates, fillers or floors having SiO2 present, they will combine. So it's not just gluing on top of the surface, it's chemically bond to the surface. Also here, potassium hydroxide is formed, and together with CO2 and water, which is present in the environment, we will find at least the potash back.
这里我们可以看到硒酸盐与含有二氧化硒的基材反应，所谓的硒化，就会形成氢氧化钾。在沉降过程中形成的氧化钾迁移到表面，并与湿气反应和二氧化碳反应，形成碳酸钾，这导致消光效果，所谓的粉化。
One of the major points that silicates can do, you can see here KOH is formed. You can see here water is released. You can see here we form something, CO2 is absorbed. Go back. We see here caustic potash is consumed, caustic potash is formed. So whatever we do, if we add acid substances, the silicate will react. If we add alkaline substances, the silicate will react. Furthermore, if we look at the equation here, if we add or remove water, the silicate will react. The pH will not be changed drastically. So the substance, sodium or potassium silicate, is a very good buffer. And that's very essential for the applications later on. And then, let's go to the applications. I just tried to give you one handful of different applications, not really connected to the construction industry, that will come later on. So what do we do with our silicates? Our main thing we do as Femberly, or where we started and it became quite big in, is binders for welding consumables. Stick electrode, flux core wired. Paper chemistry, mostly sodium silicate, de-inking pulp, thermomechanical pulp, and everything that has to do with hardening, gluing, and fireproofing of paper and cardboard. Construction. Dozens of possible applications, starting with fireproof glass and ending up with glues, wall tile, floor tile glues, flame-proofing, insulation boards, acid-proof mortars, mineral paints, mineral plasters. And last but not least, the chemical industry. Some of the things we already mentioned, precipitated silica, silicasol, also zeolites, metal silicates, and then things like textile bleaching, detergents, binders, nanotech, dust-free mixing, and so on.
好的，矽酸盐基本上可以应用在很多种的行业，它的功能是很多的，其中也包含过焊接耗材，在纸里面它也可以做成防火纸、纸板，或者是做成胶。在建筑方面，它就能做成水泥基固化剂，做成无机涂料等等的功效。然后在化学工业当中，它能是一个在洗涤剂里面的原料，也能做成催化剂等等其他的功效。
One of the most interesting points always is fireproofing. Just showing you an OSB strand board exposed to the fire of a burner. It gives an open flame, it gives a large black stain. If we treat the wood with silicate before, it looks like this. Yes, there is some decomposition of the wood. At 280 degrees, wood will decompose. But you don't have an open flame. You just have, where the heat hits, some glowing. And if you remove the flame, this one will go on burning. This one extinguishes itself within a few seconds.
好的，通过矽酸盐的使用，我们可以减少易燃性。你可以看得到，这边是一个着火的板，然后另外一边通过矽酸盐的使用，我们可以减少火的蔓延，甚至阻止火焰的发生。
The next thing, the inorganic glue. So if we mix silicates with inorganic fillers, we can make or produce glues that are purely inorganic and can be used on almost every inorganic surface and with any inorganic absorptive material. We can produce those from quite liquid, 1500 CPS, to highly paste-like 40,000 CPS, depending on what you want to do. The glue itself, due to the fact that it is absolutely inorganic, there is no organic part in, so it is absolutely fireproof, and we know that it can stand temperatures up to 1000 degrees, and depending on the fillers even more. It's water-based, not harmful, nor to people, nor to the environment. It is open for water vapor to pass. So as you all know, concrete, for example, does not let liquid water go through, but it lets water vapor to pass. Same with silicate bond systems. And it can be, and very often is used, whenever fire precaution measures are necessary, like in public buildings or in ship and aircraft construction.
好的，矽酸盐其实也是可以来生产无机胶水。这无机胶水是含有无机填料的矽酸盐组合，基本上它是可以从液体到膏状，它是有2个形态的。它联合到所有无机表面，它是可靠且永久的。它有防火的功能，它可以在多过1000摄氏度的温度下保持稳定。它是水质的，所以对人体和环境是没有害处的。它有着开放式的水蒸气渗透，适用于室内，而且它也是有着套手防火的功效。它可以用在例如公共建筑、船舶和飞机的制造，它有着防火的功能。
Just trying to show you where the foam-polysilicon glues can be used or are used by some of our customers. It's on a chimney construction, more or less as a mortar to join the stones in the chimney. It is the manufacture of fireproof elements like fireproof doors, a fireproof glass, and a fireproof door, which normally consists of metal with a rock wool core and absolutely nothing that can burn. Or the mounting of insulation materials to the ceiling, to the wall, very often done by the more pasteless silicone types, because they have the ability to keep up to 15 kilos per square meter without any mounting. So just the wet strength of the glue is enough to keep such blocks on the ceiling. Just place the glue on the board, push it up, and it will rest there for the next couple of hundred years, if not dismounted before.
好的，这些无机胶水基本上可以用在烤箱或者是烟囱的构造，它们也是可以用来制造防火元素，就好像防火门，然后它也可以用在绝缘材料的安装，比如泡沫玻璃、原棉或聚苯乙烯泡沫等等其他的材料需要防火性的功能。
Coming to my favorite topic, welding. What do we do in welding? The silicate has got an influence on the weldability. It has got an influence of the humidity uptake of a stick electrode, and it has got an influence on the stabilization of the electric arc that is necessary for the welding process. What we can do additionally is reducing fume emission, especially trying to reduce the content of hexavalent chromium, very toxic parts in the fumes. The optimized composition of the welding electrode of the binder as well as the fillers is necessary for the performance the electrode and the welding seam at the end has. And the higher the steel quality, the more sophisticated the composition of the binder and the fillers must be. What we also have to consider is the improved bonding to the core wire. So the coating should stick to the wire quite good. And in terms of flux, the silicate has got a big influence on the granulation and is responsible to a major part for the hardness of the grains.
好的，细生岩其实是很广泛的用在焊接耗材里。由于低吸湿的吸收和稳定的颠弧，焊接性很好，减少盐气的排放，在低含量的六甲格下，优化特殊高性能铁焊接的成分，改善与锌醛的粘合，优化造粒成分和改善助焊剂颗粒的硬度。
For all those not knowing of what I'm talking about, that's welding electrodes for manual arc welding, and that's flux for submerged arc welding. And the main problem we face, as I tried to mention before, we have to influence the bonding strength, we have to stabilize the arc, we have to reduce the moisture uptake, and we have to reduce the formation of chromium-6 components. What does the silicate do here? The bonding strength, we can say, the best glue is sodium silicate. Potassium is quite good, lithium is a lousy glue. For the arc stabilization, potassium, as easily ionizable ion, is the one doing the best stabilization of the electric arc. Sodium does a little, lithium doesn't do anything. if you look at moisture uptake, so how much moisture does an electrode pick up when it's just lying around without the sealing? Lithium, sodium and lithium, by far the best, almost no moisture uptake. Lithium, potassium, sodium, potassium, sodium, yeah. Sodium, potassium, no. Potassium itself, up to 16%. Much too much. And for the chromium-6, the picture looks almost the same. Lithium chromate, not volatile, no problem. Sodium chromate, volatile, not too heavy. Potassium, very volatile, very heavy. So a lot of chromium-6, still a lot, none. So what do we have to do? We have to have a good bonding, we have to have a good arc stabilization, we should have few moisture uptake and few chromium emission. So I have to mix. And that's why very often those two are used, sodium, lithium, potassium or lithium, potassium mix, just to have the good things from here and the good things from here in one single product.
好的，在焊接这一方面，其实它最主要是注重4大功能，就是连接强度、电弧稳定、吸湿，还有镉的排放量。硒酸钠有着很好的连接强度，然后硒酸钾有着很好的电弧稳定，硒酸锂或硒酸钠它有着低的吸湿能力，然后硒酸锂它有很低的镉的排放量，所以为了取到最好的焊条，我们必须搭配适合的硒酸钠、硒酸钾还有硒酸锂的含量。我们可以制造一个含有这3个元素的产品，来制造一个很好的焊条。
The next slide I would like to point out is something about paper chemistry, which is mostly paper recycling or fresh paper manufacturing, the inking bleaching, fresh fiber bleaching, tube winding, and paper glue. What you have in the beginning is recovered paper. When you do flotation, bleaching to get fresh fibers, of which you can do the recycled paper. On the other hand, wood, chipping and grinding, bleaching in several steps, ending up in fresh paper. The main purpose of the silicate here, as mentioned, is the buffering capacity. So if I add silicate, the bleaching mass here will be at a pH of about 8 to 9 and will remain there. So hydroperoxide will work best at about 8 to 9, so we can stabilize the pH there to make or to save hydrogen peroxide just by giving it the best possibility to work from pH-wise, and on the other hand, remove those ions that would kill it, like the heavy metals, and complex those by the silicate.
好的，其实硒酸盐也可以用来制造纸和纸板。从回收的纸张，通过脱墨和漂白的工艺，形成再生纸，或者是来自木材，通过纸浆漂白来制造新鲜的纸张。硒酸盐在这过程当中有着很好的稳定性，有着漂白的功能。
Besides of the producers of precipitated silicon, the detergent producers are the second largest consumer of alkaline liquid silicates. In almost every liquid detergent which has a pH, a high pH, some silicate is present. Very often used acting as buffer, as builder, and a source of alkalinity. So you need the buffering to keep the pH as high that all the ingredients can work and the washing really works. You need it as a builder because the water hardness metals, calcium and magnesium, have to be removed. and you need some alkalinity to do the washing itself. Very often sodium silicate in a molar ratio of 2.0, sometimes up to 3.5 is incorporated in those detergents, mostly when they are designed for public use. If we go into industrial use, sometimes it is changed to potassium, because there we have very, very alkaline detergents with very high amounts of silicate and of alkalinity, and sodium silicate, if we go down on a molar ratio of 1.0, will precipitate. So sodium metasilicate has a solubility of roughly 20% at 20 degrees. Potassium meta or orthosilicate, you can go up in the concentration, let's say 55 up to 60% without any problem. No precipitation will happen there.
好的，其实矽酸盐也可以用在洗涤剂里，在洗涤剂的生产中，它可以充当冲缓剂、缓冲剂、助洗剂和碱度的来源。摩比为2到3.5的矽酸钠通常用于生产消费者使用的洗涤剂。摩比0.5到1的矽酸钾主要用于制造机械或工业洗涤剂，特别是当要求矽酸盐浓度高于20%的时候。
Having a quick glance at the biggest consumer of sodium silicate solutions, the production of precipitated silica, which is at the end used in tires, used in toothpaste, used in abrasive cleaning agents. So what they do, as mentioned before, they put some acid to the silicate. The silica will precipitate as a white powder, also an amorphous white powder, which is used in very many following applications. And the silica sole, most of you will know it, opalescent liquids, undissolved silicate side, but nano-sized, let's say 7 to about 50 nanometers in diameter, particle size, just stable in water, not precipitating.
好的，矽酸盐基本上也是可以用来生产2氧化硒，或者是叫做硒溶胶，可以透过添加无机酸生产沉淀2氧化硒，然后透过离子交换去除碱金属离子，生产2氧化硒溶胶。
Let's try to summarize what I told you. So the soluble alkaline silicates and water glasses are salts of silicic acid. Thus, they are quite close relatives to about 90% of the rock formations we live on, and of about 100% of the Earth's mantle that is below that tiny little crust we are living on. You can use the silicates in a very wide application field, very many different industries, from binders in the paint down to precipitated silicas or zeolites, and as a specialty, even as anti-corrosion agent in drinking water system, which I don't know how it is here in Taiwan. I know in Switzerland, in Central Europe, Germany, that's very often used, that you just place some tiny amounts of silicate up to 20 milligrams per liter into your drinking water. It is absolutely harmless and it prevents corrosion in the drinking water systems. Second, they're inorganic. They are non-toxic, they are non-allergenic, and they are eco-friendly because they are close to nature products themselves. And except that we have to add some organics, there is really absolutely no organic present, as you can see from the manufacturing route. In a furnace at 1400 degrees centigrade, there is no existing organic who will remain there. It's burned away. Most of the chemical and physical properties we can influence, and we can adjust it to exactly your needs, to the requirements of your applications.
好的，我们就来到摘要。可溶性矽酸盐和水玻璃其实就是矽酸盐。 因此与来自地幔和地壳的天然存在的矽酸盐是很相近的。它们可以用于许多不同的行业，作为涂料工业中的粘合剂，作为建筑中的水泥加速剂或粘合剂，作为防火胶，作为焊接材料制造中的粘合剂，在洗涤剂里作为缓冲剂和碱源，作为生产硒溶胶、沉淀二氧化硒或废石的原料，作为饮用水系统中的活性防腐剂等等。矽酸盐是无机的、无毒的、无过敏性的和生态友好的。大多数化学和物理性可以根据应用要求进行精确调整。我们可以克制产品，以达到您要的需求。
Our portfolio at Van Baarle at the moment consists of about 200 different products, starting at the pure sodium silicates, ending up at mixtures containing sodium, potassium as well as lithium. So depending on the application and even depending on different customers in the same application, there will be slight differences in the products we sell. So we are not a supplier having 3 different qualities, take it or leave it. We will look into your application, we will help you to improve it, and we will deliver exactly the product customized to your needs. So if you have problems with silicates, ask us. It is our job to figure out how we can overcome those problems, how we can improve your application and our product. So we really produce the exact quality for you.
其实泛玻璃的实际产品组合包括200多种不同的矽酸盐产品，从纯的矽酸钠、钾和矽酸锂到各种混合的类型，包括以上2种或3种，如果需要还可混合使用，以完美适用应用。让我们知道您所要的是什么，您遇到的是什么的麻烦，因此我们可以完成我们的工作，根据您的要求定制矽酸盐给您。泛玻璃生产并提供您需要的精确品质。
And that's also the meaning of our claim, better for you. It's not better for you, it not meant we are better for you, it meant we want to be better, and we want to be better because of you, for you. That's it. Thank you very much. I hope it was not too technical, but nevertheless we have a quite complicated substance, and without a lot of technique behind, it will not work. Thank you very much.